Hello everyone, I'm Yuchen You. Today I'm going to talk about the degradation of organic pollutants by graphite carbon nitride, composite photocatalysts under visible light. This is the outline of my experiment. First is the motivation. With the progress of the times, industry has gradually developed, but the environment has also been destroyed, resulting in a lot of water pollution. A few years ago, scientists have discovered that titanium dioxide can degrade pollutants in water, but it must absorb ultraviolet light. Therefore, I studied the graphite carbon nitride photocatalysts that can absorb visible light and degrade the organic dye, rhodamine B, and evaluate its degradation efficiency. Let me talk about the principle of photocatalytic reaction. By irradiating semiconductors with light, when the energy is greater than or equal to the energy gap, the electrons in the valence band will be excited to transition to the conduction band, leaving the relatively stable electron holes in the valence band, forming the electron hole pairs, and they can accelerate the reaction. Different from the single photocatalytic reaction, electrons with stronger reducing ability in the conduction band of S1 and holes with stronger oxidizing ability in the valence band of S2 will be retained. The electron holes of S1 will combine with electrons of S2. And then I'm going to talk about the experimental materials. The materials of graphite carbon nitride are rich, and it is also easy to synthesize. It has a suitable energy gap for the visible light and a better chemical stability. The cost of iron oxide is low, and it can absorb visible light. Moreover, it is magnetic and easy to recycle. The dye used in the experiment is rhodamine B, which is a toxic organic dye, and the next slide shows the equipment. The experimental equipment are magnetic stirrer, ultrasonic cleaner, photocatalytic reactor, centrifuge, and spectrophotometer. The next slide shows the experimental methods. Wrap the beaker with aluminum foil to avoid light exposure. Pour 99 ml of deionized water into the beaker. Add 0.01 grain of photocatalyst. Stir for 5 minutes and oscillate for 10 minutes. Add 1 ml of rhodamine B solution. Stir for 30 minutes. Then put into the photocatalytic reactor and take samples every 10 minutes. Separate solution and photocatalyst with a centrifuge. Measure the absorbance with a spectrophotometer. The slide shows the results of experiments. This is the experimental data. The blue line means that the added photocatalyst is a composite photocatalyst synthesized by graphite carbon nitride and iron oxides. The orange one means a single photocatalyst, graphite carbon nitride, and the gray one means no photocatalyst. The data shows that the degradation efficiency of composite photocatalysts in 1 hour is 95%, better than 75% of single photocatalyst. And then I'm going to talk about the following experiments. In the following experiments, I will change the molarity of the rhodamine B solution, the doses of photocatalysts, and the pH values of the solution, and measure the degradation efficiency. Thank you for listening.